Hi everyone! Today our lesson is about right triangles, and specifically finding missing measurements of a right triangle by using Pythagorean theorem. For this lesson, you'll need a piece of paper, a pencil, and a calculator. I'd like you to pause the video to copy down the notes outline. After you have all of this down, unpause the video and we can go over the notes together. Pause the video now. Welcome back! Okay, we're going to start by learning the parts of a right triangle. So we learned that a right triangle is a specific name for a triangle that has, you guessed it, a right angle. We know that triangles have three sides, so if it's a right triangle, two of the sides are called legs, and the longest side is called the hypotenuse. Go ahead and fill in your notes as well. The hypotenuse is always across from the right angle. So I'd like you to practice labeling the hypotenuse now. We're going to call it side C. How do I know which side is the hypotenuse? It's always the longest side. So here we're going to draw our arrow across from the right angle. This is the hypotenuse, side C. Take a moment to label side C on the next two triangles. What is Pythagorean's theorem? Well, we credit a Greek philosopher named Pythagoras, who made the theorem famous 2,500 years ago. The Pythagorean theorem is one of the cornerstone math formulas that's used in algebra to find the distance between 2 points and in geometry and more. The Pythagorean theorem formula is a squared plus b squared equals c squared, and c is the hypotenuse, which is always the longest side. We are now going to use Pythagorean's theorem to find the hypotenuse. Let's see if I can zoom in more. We'll see. Not sure. The first step is to plug the numbers into the formula. So we have to label the sides A, B, and C. Well, we know C is the hypotenuse across from the right angle, and the other sides are A and B. It actually doesn't matter which you label as A and B. My preference is to make the smallest side A and the medium side B. And the reason it doesn't matter is because of the commutative property of addition. The commutative property of addition says that if we change the order of the addends, we'll still get the same result. So let's see if it works. Now we're going to substitute the side lengths into the formula to find what we need. So if A is 9, A squared is 9 squared, B squared is 12 squared, and C squared is x squared. And it's an equation. 9 squared is 9 times 9, which is 81. 12 squared is 12 times 12, which is 144. Step 3 is to simplify. So let's simplify what we can. 81 plus 144 is 225. So 225 is x squared. Now, how do we get x by itself? Well, we learned previously that to undo square, we have to take the square root. So let's take the square root of both sides. The square root cancels the squared. And we get x by itself is x equals the square root of 225 is 15. So this x is equal to 15. Okay, we'll do another one together. So again, we're going to label our sides. I'll choose a different color this time so it's easier to see. The smallest side is A, which is 5. The medium side is B, 8. and C, our hypotenuse, is x. We plug it into the formula. 5 squared plus 8 squared equals c squared. And step 2, square the integers. 5 squared is 25. 8 squared is 64 equals c squared. 25 plus 64 simplifies to 89 equals c squared. And we'll take the square root to get c by itself. So it does say round to the nearest tenth. The square root of 89 on the calculator is 9.4, rounded to the nearest tenth. So c equals, or x equals, 9.4. Okay, please pause the video now to complete the third question on your own. Okay, now we're going to use Pythagorean's theorem again, but now to solve for a missing leg. So the steps are a little bit different. There's one more step, and that is we have to subtract. So I'll go back to black, and we'll label our sides A, B, and C. Well, we know C is 10. The smallest side is A, and the medium side is B. So A is x. A squared is going to be x squared. B squared is going to be 8 squared. And C squared is 10 squared. So x squared plus 8 squared equals 10 squared. Let's square the integers. X squared plus 64 equals 100. This is an equation. We're solving for x, so we have to get rid of that 64 by subtracting 64 to both sides. (64 minus 64 cancels. On the left, we're left with x squared. And on the right, we have 100 minus 64, which is 36. We take the square root of both sides. The square root cancels the squared, and you get x equals 6. All right, I'll do one more with you and leave the third one for you to do on your own. We'll label the sides, starting with C. The hypotenuse is 23. A is going to be x, and B is 18. So we plug it into the formula. X squared plus 18 squared equals 23 squared. Okay, so I'm going to have to get my calculator out for this one. X squared, I know that 18 squared is 324. And 23 squared, 529. So we're solving for x squared. We need to subtract 324 on both sides. Those cancel. X squared is left on the left. And 529 minus 324 is 205. To get x by itself, we take the square root. Those cancel, and you get x equals the square root of 205 rounded to the nearest tenth is 14.3. So pause the video and complete the third one yourself. Alright, so I'm done with my part of the lesson, Thank you for learning with me. Please write your summary, take a picture of your completed notes, and upload a picture into Focus. I apologize for my tablet handwriting. Hopefully, this improves as we keep going. Thanks again, everyone. Bye.